I wanted to take the opportunity before we get to alkene reactions just to look at aromatic rings. Okay, and basically what I'm going to look at is called cyclo, which means a circle, cyclo alkenes. Cyclo alkenes, and there's only one that's really important, but let me explain what we mean by cyclo alkenes. So what we will have is we will have carbons bonded to another carbon, but this carbon might be double bonded to another carbon with oxygen to another carbon, making this an alkene. But then this carbon goes and bonds to the original carbon so that we form what is called an aromatic ring. Now in this case, if we were to just fill in our hydrogens, remember we have to have 8 everywhere. This is more or less what the the structural formula looks like. Okay, and this is an example of a cycloalkene. Now how would we name it? Well, exactly the same. Usually we wouldn't need to number the chain because, I mean, where are you going to start numbering? It's a circle. Okay, so we don't have to number the chain unless there are more than one a double bond. If there's more than one double bond, we might have to number it. But in this case, it doesn't matter where you start numbering. And this one, as you can see, is a propene. Okay, because it's got 3 carbons, it's a propene. But to show that this propene is in a aromatic ring, okay, why it forms a closed circle, we use the prefix cyclopropene. So this is cyclopropene. Now if we were to look at the next one, that would be 4 carbons in a ring, and let's say we had double bonds here. Okay, now obviously we'll need to number. This is 1, 2, sorry, we'll start with, well, if we start here, it's 1, 2, 3, 4. So this one would be cyclo, okay, then 1 comma, so there's 1 double bond at the first carbon when I started numbering, 3, because it could have been here, then it would have been 1, 2, okay, but it's there now, so this is 1 comma 3, cyclo 1 comma 3, I lied, cyclo pro 1, actually propa 1 comma 3 diene. Okay, why diene? Because there's 2 double bonds. Okay, propa is now just the prefix that we'll use when we have more than one, okay, so that it sounds better, not prop 1 3 diene. And yeah, that's it. It's really not that difficult. But the important one, the one that will really come into play a little bit later when we do polymers, is when we have 6 carbons. In other words, it looks like this. 6 carbons like this. And every second one has a double bond. So we have single bond, double bond, single bond, double one, single bond, double bond, single bond, double bond. You see that? Where each one of these will only have a single hydrogen. Okay, and this one can form a special polymer that we will look at later on. Don't be intimidated by that, but just so that when we get there, that you are not all of a sudden caught unawares of this special cycloalkene. That's the one we're going to look at more later on. What is his name? Well, you might know him as benzene. Okay, that is his commercial name, benzene. His proper UiPac name then would be cyclo. Okay, and then if I start numbering anywhere, as long as I start numbering and go in the direction of the double bond, so 1, 2, 3, 4, 5, 6. This would be cyclo. Okay, there's 6, so it's hexa. Hexa. And then our number 1, 3, and 5. Look how it's on the odd numbers. 1, 3, and 5. Triene. Triene. Okay, that would be cyclohexa 135 triene would be benzene. Okay, it was great teaching you this topic. It's not very difficult, even though it might be slightly intimidating, but hopefully you find it is not that bad. So thank you for watching. I'll see you then in alkene reactions. Bye.